Hello, everyone. Welcome to the episode of Munro Live. I'm Chris Fox, low voltage systems lead engineer here at Munro. Today with me on this podcast, we have Chris and Ryan from Zoox. So thank you for joining us. Do you guys mind doing a quick introduction? Start with Ryan. What do you do with Zoox?
Sure. I've been at Zoox almost 9 years now. I'm the director of our sensor engineering teams, as well as systems and safety for what we call advanced hardware engineering.
Yeah, I'm Chris Stoffel, our Director of Industrial and Creative Design. I've been at Zoox a little over 8 years, so Ryan and I have quite the history together. And thank you very much for having us on today. We're really looking forward to chatting with you guys about all the cool things we're doing at Zoox.
Let's start off with what's the history of Zoox? Where did it all start?
Yeah, so Zoox is over 10 years old now. We've started really with the core mission of improving people's lives, moving from A to B. And for us, that is really around developing an entire really solution around mobility using autonomy design, full stack AI technology, the service, the operations, everything behind that to really give you a better ride. And really, our approach for that is to gather the right people to bring that journey to life, and do it in a way that I think is going to really kind of hit people's imagination when it comes to what a robotaxi should be. Not just maybe a vehicle that drives itself, but truly a different type of product that tries to kind of gives you a unique experience that you can't get anywhere else.
So if I'm not mistaken, it's a 4-seater vehicle, right?
Yeah, four-seater vehicle, fully symmetrical, bidirectional, fully autonomous robotaxi designed from the ground up.
Okay, so that definitely puts you guys in a different position than most robotaxis who will retrofit existing vehicles. So what made you want to design from the ground up?
Well, I think, when we looked at the problem statement, how do you improve people's lives moving from A to B? How do you just make that experience better? It truly required a different type of product, one that had to support the demands of autonomous driving, which Ryan can speak more to in terms of those challenges, but really to deliver, I think, on a unique experience for riders as well. They've always been a passenger in a vehicle or public transportation or whatever that may be, and not really had the agency that they may have in their own vehicle. But in their own vehicle, that demand of driving is something that you can't really let go of. So how do you take in all the best parts of the current ways of moving into and put it into one type of product that's also safe, consistent, and really desirable? And so for us, it was really around one, the constraints around AI. So don't hold that back. And Ryan can speak more to that. And that kind of lends itself into the boxy shape, the redundancy, the sensor locations and hardware and whatnot. But really then, what does it mean to deliver a unique experience? And for us, it was how do we bring people something that's really incredibly desirable, but also allow them to kind of create their own journey and didn't really demand their attention. And so we really landed on this idea of, the typical experiences we like. We like to hang out in rooms or on couches or in lounges or on a train or a bus, whatever that may be, in a different environment that unplugs you from the driving scenario. And so at the same time, we realize people move around differently at 6 a.m. versus 6 p.m. And so what they want to do in the vehicle is going to be unique. So for us, whether it's you by yourself, you have this great quiet space that's yours. It doesn't demand your attention. Whether or not you just want to get in, have plenty of legroom and space around you and sleep and hit go, we have you in that scenario. Or if you just want to listen to music or have a call, we've got you there too. If you want to, if you're with your partner or whoever you're with in that moment that you want to have a kind of a journey with, they're right next to you with this big open space. But then if you're with friends or family, they're really that separation that really changes. I think what maximizes robotaxi is we create this social space that you can sit exactly how we're talking today, just as kind of humans are designed to, that you don't really get anywhere else. That kind of really maximizes and really pulls you out of being in a vehicle and really into a robotaxi. And we really wanted to maximize that. And I think AI technology is so awesome. We kind of wanted to put it in an equally awesome type of vehicle that really kind of think was different than a regular vehicle. And hence the kind of the unique ground up nature that we've been able to bring forth, for at least from the rider perspective. But there are some pretty serious improvements for just the technical and engineering perspective as well that Ryan can probably speak more to.
Yeah. I mean, you nailed it, Chris. I mean, I think the experience and sort of how the customer interfaces with this vehicle was so key in that ground up vision, and the fact is when you get into Zoox, it's not stepping into, opening a door in a 4-door sedan, sitting down in front of a steering wheel, seeing a brake pedal, it's removing all of that, right? It's really making it about the rider. And in addition to kind of that experience piece, which I think is maybe a little bit more clear when you just look at this concept we've come up with, there's a lot under the hood that we've tried to pack into this thing to really design it for autonomy. And so some of the themes we'll talk about today, and I'm sure Chris, probably have a few ways you want to take this, but some of the themes around avoiding single point failures that result in a total loss of the robot. So maybe we'll talk a bit about the sensor suite, but we also have like our Ethernet backbone, our CAN buses, high voltage batteries, a number of these systems that are designed to avoid single point failures. We've also built in operational redundancy, allowing that bi-directional driving of the vehicle up to 75 miles an hour. We have extended operational life with our battery capacity, that really enables us to keep that robot on the road as long as possible to serve our customers. And we've done some tricks in simplifying the movement of the vehicle with four-wheel steering that we may get to talk a bit about today, where we can, kind of do the crab walk, right, and get all four wheels going in that same direction, or have them opposing to really minimize our turning circle, to really increase that maneuverability and control of the platform.
Interesting. Let's talk about the body first. Because you're building a vehicle from the ground up, you mentioned going up to 75 miles an hour. How does that play into like NHTSA regulations, airbags and seatbelts and everything else like that, and crash standards?
Yeah, I think, what we wanted to do was make sure, even though it may look different and look special and unique, it has to live in a vehicle world, right? And so what we're really proud of is, why we started this from the ground up was really to deliver a vehicle that's safe in all environments and can go on the road just like a normal vehicle that we buy today. It is the first kind of robo-taxi that's fully self-certified to FMVSS safety standards in the United States. We're really proud about that. On top of, we touched upon this with the experience a little bit, we have these 4 equal seats on the inside. That safety rating is for each one of those seats individually. So, we're really happy to have kind of that equal type of safety standard across the vehicle. And, I think for us really, the challenge of developing something that was, again, from the ground up, it had to live in a vehicle world, is kind of what allowed us to really provide some really unique innovations to the vehicle from a safety perspective. You've never really seen a communal seating, fully homologated vehicle on the roads before, and that required a lot of airbag safety crash innovation, which we've worked with some amazing partners on and amazing talented people at Zoox to develop that for the first time. And we're also bringing in unique situations for vehicle interior constraints as well. And then, of course, just the body structure, the unique bidirectionality of it, having that type of system work not only from a bidirectional performance standpoint, but then from a bidirectional crash standpoint as well. So some really cool stuff that we've brought into place simply at the end of the day to have that great rider experience, right? To do that, we know that there's going to be optionality. We know you have choice. We want to be the best choice. And so how do you create something that's desirable and just looks really interesting and cool, but at the same time, the underlying safety factor, safety is very foundational to Zoox. How do we make sure that people are aware of that? They feel that they have that sense in the vehicle, that we've taken all of that very seriously underneath the skin as well. Hence the innovations for safety. And then really just from a look and feel standpoint, trying to make it look approachable and timeless and a little bit, kind of calm, so it doesn't really demand your attention. What you're getting. It's very truthful and honest. It's a robotaxi. It's got sensors on the outside, etc. We're exposing some of the materials as well to make it look very honest. And so, no surprises with what you're getting with the vehicle. And we really like to highlight that for our riders.
Okay, talking about the body still and the materials. What kind of body materials are you using, both interior and exterior?
So the body itself is designed out of CFRP, and it's basically, again, the nice thing about the symmetry of the exterior, that actually plays into the engineering as well, the B side, and that you see. It's very, very symmetrical. It's basically quantity for 2 parts in the vehicle. So we're able to replicate that quite easily. There's also, aluminum subframe structures that we have in there. Of course, the HE batteries and those systems, which are quite common with what you see in construction for other OEMs. Traditional HVAC units. Ryan touched upon redundancy as being something really important for our vehicle. And so what we've done, being able to complete the mission, I think is really important. And some of the areas that we have looked at in terms of redundancy are not only, Ryan will speak to like the AI hardware side of things, but from the structural side of things and from the vehicle side of things, we have 2 EDUs, we have 2 battery pack setups, we have 2 HVAC units, 2 steering racks. We do have equal kind of designs and basically these large, what we call drive modules concepts that are on either end of the vehicle, basically subframes and all the structure and componentry that's involved with those. that themselves are basically one part number that can kind of come in and attach to the vehicle. And if we ever have an issue where we have to repair something on the vehicle, that swap out is pretty quick and easy. Again, trying to maximize uptime. And we kind of see that symmetry, not only again on the outside, but also on the inside. But then what's cool from the compute standpoint, which Ryan can speak to, is, we really take that philosophy into the AI hardware as well.
Okay. As for the batteries, are you allowed to discuss the cell selection? Are you using pouch cells, prismatic, cylindrical?
So we're not talking about cell selection, but it's about a 134 kilowatt hour battery pack split into two setups. It operates as one. It can work individually as well in terms of if we need that backup. It's capable of our charge rates, we design it differently, right? We're not trying to pull really fast 0 to 60s or doing a really high draw, or we don't have to have a high C rate to do fast charging because we own and operate these vehicles. Think of them more like public transportation and how we charge and use them, so we can have some really nice, like, long cycles with them as well. But it's not necessarily a drastically different setup than you see in a regular EV today. Just the architecture itself is different for that redundancy side.
So with the symmetry, do you have two separate radiators and condensers, or is it all on one side of the vehicle?
Two separate.
Okay.
Mhm.
Good. Okay. Now, did you guys design the inverters and motors in-house, or were those outsourced, sourced, or how did that all work out?
So we have our own internal specs based on our drive cycles and basically how the vehicle operates, but we work with an outside partner to supply those.
Probably maybe worth highlighting, we consider ourselves an OEM, right? So Zoox manufactures our own vehicle. But as Chris kind of alluded to, a lot of the components, some of the large components that go into the vehicle, we work with external suppliers, just like an OEM would, tier ones and so forth, to basically execute on our requirements and deliver the pieces of that vehicle that we need.
So can I ask on the motors, are they hairpin or wound motors?
We're not sharing the details of that right now, but it's at the end of the day, we really want to strive for efficiency and reliability, right, in our setup. So nothing really fancy in that regard, and also cost and those are factors as well with our decisions. But it's really around how do we build something that we can get for meets our specs, reliable, going to complete the mission. That kind of meets our, again, performance specs aren't that drastic. The vehicle is not incredibly lightweight, right? And there's not only 133 kilowatt hour battery pack, but there's redundancy. It's it holds 4 people, etc., plus all the autonomy hardware. So their performance is still high, but not having to do the full pull, 0 to 60s, or to be at certain high temperatures for X amount of time, like if you're doing track time or high performance time. It's been kind of a nice luxury from the engineering side to think about that different use case and those different requirements, which kind of trickle down into all the other components. Again, really going back to that, not a car type of product, it's a different type of product, yet we apply the same methodology. Has been kind of a nice opportunity.
Okay, let's move into the sensor suite. What kind of sensors do you use? Where are they positioned in the vehicle?
Yeah. So probably just the first thing to mention is that the approach and the design philosophy around the sensors really ties back into that kind of ground up design that we mentioned at the beginning. And one of the key levers that we were able to pull here was putting those sensors exactly where we wanted them. And so actually, Chris and I team, worked very closely together years ago when we were putting together the first napkin sketches of this thing to figure out kind of where we wanted everything to go and how we would integrate that. And went through a couple different iterations to land where we are today. So as far as some of the design philosophies, it's all about redundancy and diversity. So I think those are two of the key words for us here. And what we mean by that on the redundancy side is we want, for example, if you have a camera, instead of just having one, you'd have two, right? And instead of one LiDAR, you'd have two. And so this idea of redundancy in the components, similar components, and basically getting that overlapping coverage around the vehicle to see the world around us, so that if we lose one of those sensors, we're still good, right? And I think that's a really key tenet of that redundancy piece. And on the diversity piece, that's where you get into like, okay, I have a camera, but could I augment that by adding other types of sensors, by adding a LiDAR, a radar, and we'll go through some of those various sensors now. I will mention, Chris, I saw a really nice video that you had put together pretty recently, I think in the last couple of months, where you did kind of an in-depth look at the role of some of these sensors in ADAS. So probably a lot of this is pretty familiar, maybe to some of your viewers. But we'll talk about some of those technologies. So I mentioned cameras. So we do use color cameras, RGB. Think about mimicking like what your camera on your phone might see. A similar data product there. So we've got those around the vehicle. Some of the highlights of cameras, being able to see traffic light colors, for example, distinguishing red from green. It's actually a unique modality in that sense. It's the only type of sensor that can really tell us that state of the traffic light directly. Cameras also offer really high resolution, so being able to see finer details at longer distances, which is really helpful. Thinking about those highway driving use cases, right, where you're driving at high speeds, and even dense urban cases where you just want to be able to see further ahead with more detail. Recognizing attributes from pedestrians, gestures, for example, facial expressions, all that kind of stuff, plays into the camera use case. So in addition to cameras, which I think we're all fairly familiar with, we've got some other types of sensors. So we have our LiDAR sensor, and this is a sensor that is an active sensor. It sends out laser light. That light is in the near infrared portion of the electromagnetic spectrum, which means it's just outside what humans can see, right? So you wouldn't see the laser coming out of our LiDAR. It goes out into the environment, hits objects, bounces off, comes back, and we can basically use that to determine how far away objects are in the scene. One of the really nice things about LiDAR, partly because it's using this laser light, is that we're able to do this with really high resolution, both spatially and in terms of depth. So we can build up these really dense point clouds, that's what we call them, around the vehicle, that give us this three-dimensional information about the world around us. Using the multiple LiDAR sensors that we have on the vehicle, we get that 360 overlapping coverage. LiDAR, I'll touch on this. Maybe this isn't always covered when folks talk through LiDAR, but I think personally one of the most useful aspects of LiDAR in autonomy is that you actually don't need to classify an object for LiDAR to be useful. And what I mean by that is in the AI, the jargon, that we kind of use around this classifying something is saying, not only have I detected a thing, but I know that thing is a pedestrian or a vehicle or, something more specific. With LiDAR, you actually don't need to go all the way to the classification step for it to be incredibly useful because as a robotaxi, one of our fundamental tenets is not to hit stuff. And as long as a LiDAR can tell you that something is there, it might not, you might not instantly know exactly what it is, although LiDAR can do that. As long as you know something is there and how far away it is, you can not hit it, right? And so that's generally a great thing. And so we really like LiDAR for that reason, among many others. Moving ahead, we've got radar. So similar to LiDAR, radar is an active sensor, sends out electromagnetic radiation, millimeter wave radiation, which is much longer wavelength than what LiDAR uses. That radiation hits objects, reflects back. We're able to use that to measure, again, the distance to things. So radar gives you distance. One interesting piece of the radar data product is a direct measurement of velocity. That's very common in sort of standard automotive radar. So you get a direct measurement of the radial velocity of objects around you, which obviously is a very useful input. One really huge advantage to radar is that it's incredibly robust to adverse weather conditions. It starts raining, it's foggy, radar is king in those conditions, whereas, cameras or even LiDAR, these optical sensors tend to degrade a bit more in those conditions. And we actually spend some time mitigating that with active cleaning systems and various approaches to improve the performance. A couple other sensors I'll mention quickly. We've got thermal imaging. So in addition to color imaging, we actually have, heat sensors on our vehicle. So yeah, double thumbs up. We like that a lot. If you think about that canonical case of pedestrian walking across the street at night, very low light conditions, just as our human eyes sometimes can struggle with that, right? Our color imagers on the vehicle can also have some degraded performance. So by having these thermal imagers on the vehicle, those pedestrians light up like the sun. Actually, that's ironic because the sun is quite dim in a thermal imager. But anyway, the the pedestrians will light up very brightly in those images as they walk across the street, day or night, and that's a really nice tool for us. Probably the most interesting example that I've seen from our vehicles here, we actually saw in our thermal imager a rat running across the street carrying a burrito. And so that was a hungry rat heading to dinner. But we picked it up very clearly in our thermal imager, which is kind of funny. We use microphones on the vehicle, some obvious use cases there. So emergency vehicles are really
exactly
big one, right? So lights are great on emergency vehicles. You can't always see the lights, it turns out, right? And so obviously having the sirens and that signal is really important for us. And then in addition to that, we've got IMU and GPS sensors, IMU for positioning, measuring acceleration, and then GPS also for positioning and a sense of absolute global time, which is very useful to the robot. Quick summary there. And in terms of placement, we've got these 4 pods on the corners. You've probably seen them in our design. Again, Chris and I, our teams worked very closely on that one. And, one of the nice things about those pods is that we're able to iterate pretty quickly on the sensors that are in those pods. So we intentionally design those pods in a way that, not only do they jut out to give us nice visibility around the vehicle, maybe jut is too harsh of a word, but anyway, they lean out a bit.
They're okay.
Yeah,
they look pretty good.
they lean out a bit.
Yeah.
Anyway, they provide that really great visibility, especially for the spinning LiDAR. But we can iterate quickly on the sensors in those pods, which lets us update technology and keep up with the state of the art. So lots of really nice things there in that aspect of the design. We've also got some long range cameras on the roof. We've got some fisheyes around the vehicle to give that nice wide angle perspective for short range sensing. Radar that are kind of hidden behind the fascia in various areas. The vehicle's really stacked with sensors.
Do you have any internal sensors to verify, like, hey, somebody's still in here? Or...
Yeah, we've got a interior camera. The camera is located kind of in the center of the roof bow and the roof there, and provides. It's almost a sort of a passenger feature there that allows folks to interact a little more closely with our teleoperators if something were to go wrong, if they need to call home, that kind of thing. So we have that built in.
Yeah, one story around, I think, the integration that we've done with sensor pods. We always had the idea of architecture around this 360-degree field of view, this quadrant design that was always foundational. But I will say, kind of the early ideas that we were thinking about with the architecture of where sensor placement was a little more integrated at first. And that was kind of the ideal design, and we didn't have good data to say if that was good or not. With our development fleet, basically we have Toyota Highlanders with our sensor architecture on them that drive around. We were able to learn a lot more as we we're kind of moving through that development of kind of AI in parallel with the vehicle. And I remember, very specifically when Ryan came to me one day, a little like hesitant to have this conversation, was saying like, Chris, we need to pull out some of these sensors. Like we really do. We're not seeing maybe the things that we want to see in certain situations now that we're driving more. And I think, having this vehicle again be ground up kind of gave us the opportunity to make a change very quickly. Within 3 months, we had gone to a pretty integrated architecture into the external architecture that you see today. And being able to do that has given us, again, we want to unblock our AI development and not hold that back whatsoever. And I think being able to have those teams in-house, be able to still have this, looks like a designed element, on the vehicle, it still doesn't look like a Band-Aid, is something key to having that finished product for riders. And to Ryan's point, we've even made continual updates to those sensor pods today with minor tweaks and changes based on what we're learning on the day-to-day basis from our development fleet.
Are you allowed to mention the suppliers of those sensors at this point, or is that too early?
We have one supplier that we've announced publicly, actually. We've announced our partnership with FLIR for our thermal camera. So that one we can disclose. For the other sensors, we can't mention them at this time.
Okay. Can you elaborate a bit more on the AI? I keep bringing that one up. That seems to be bit more unique in this field?
Yeah, sure. Just in terms of kind of on the algorithmic software side of things.
Yep.
Um, so, my team basically provides a lot of the sensors from a hardware perspective, which is really where a lot of that funnel starts. So there's a data product from cameras, LiDAR, radar. This data product flows into our compute system. That's where it's ingested and used by the algorithms, right? By the software that's written by our AI teams. In general, just talking broad strokes here, we implement fusion at Zoox, which is pretty common, across the industry, pretty standard. There's different ways you can implement that, early stage, late stage fusion. These are all things that we incorporate. We're, constantly looking at ways of using our sensor data more and more, through all the miles of, logs that we collect on public roads to solve, a number of scenarios that come up. But in general, we run algorithms on individual sensors, and then we fuse the outputs of those sensors, and we do like sort of all levels of fusion there to take advantage of the diversity that I mentioned earlier in the sensor suite. We want to make sure that LiDAR data is complementing the camera data and the radar data and so forth.
Can you walk through a couple maybe fringe cases you've come across so far using, because you've got a unique sensor layout that we don't really see too often, definitely not on an L3 and rarely on an L4?
Yeah, sure. So there have been some edge cases, let's say, that have come up, or more rare cases that have come up that I think have really helped to validate our approach here in terms of using different types of sensors on the vehicle. One case, I can kind of describe this verbally. Picture's worth 1,000 words, but driving and having a row of parked cars along the shoulder, and we were kind of driving forward. And sort of at the last moment, there was this blast of water that kind of came out in front of the vehicle. And what it was somebody on the side of the road that was actually washing their windshield, from one of the parked cars there. We couldn't see the person. We just saw this, big blast of sort of water coming out, and it included like steam and stuff. And that was an interesting use case for us because the cameras and the LiDAR both actually struggled to kind of see through that particulate cloud, right, in the moment there, that suspension in the air. And on their own, although, eventually we're able to detect the pedestrian, it wasn't immediately obvious that there was a pedestrian there. And the pedestrian had kind of like leaned out into the road a little bit, so it just didn't come close to being an actual incident or anything like that, but just describing a case here where a pedestrian being sort of clouded in particulate can be a little bit difficult to see.
Absolutely.
And so what was interesting there, though, is that, again, long wave IR and thermal imaging saving the day. So we were able to pick up that pedestrian super clearly with plenty of advance notice as we were driving towards that sort of particulate cloud. Because we could, effectively kind of see through it. So we run into these kind of cases. This example kind of validated the thermal imager. I think we run into cases all the time where we see, great, we had radar, great, we had LiDAR, and we're able to continue really justifying the high value that those sensors have brought to our overall suite. And it's kind of interesting because, when you start this problem, call it 10 years ago, you don't always know all of these, edge cases, all of these long tail scenarios. You try to do your best. And I think the approach that we took, I feel pretty good about, which is that we tried to over engineer in a sense. We tried to put as much on here as we thought we'd ever need to solve this problem and get to, what we consider a viable product to put on the roads with passengers, a safe product, right? And I think, we are seeing a lot of examples of where that's coming true in the form of these sort of long tail scenarios.
Yeah, it does seem that like 80% of your time is spent on the fringe cases, like the basic ADAS functions usually pretty quick. It's always the details that take the longest part.
Yeah, and like from a philosophy standpoint too, completing the mission for for a rider, I think, is key. Ryan touched upon the redundancy that we have within our sensors. We'd also have, fail-safe issues as well. You can lose a certain sensor or two and still complete the mission, or at least safely get to the side of the road. I think, again, not holding back the success of AI and our self-driving at this early stage was key. We're not beholden to selling a vehicle at millions of units and having a certain cost target. So we're able to kind of bake in basically the right engineering approach, we feel, to achieve our targets that we've set up for ourselves to be able to have that best service for riders.
Okay. Then with the sensors, what can you mention, like the longest range versus the shortest range sensors you have?
Yeah, in general, our coverage goes out 200 meters, 360 overlapping redundant coverage. We care just as much about the very, very close stuff as we do about the far stuff. So, and the very, very short range, you think about pedestrian interactions with the vehicle, even the vehicle body itself, right? And making sure that we can really pick up that stuff that's all around the skirt of the vehicle, all the way out to those longer ranges. The really long ranges start to become relevant at higher driving speeds. The vehicles are currently driving the 45, in our geofences. And we, the vehicle I mentioned earlier, bidirectional, fully capable from a vehicle platform standpoint of going up to 75. So when we think about these higher speeds, those longer ranges certainly become a lot more relevant.
So you mentioned the geofence areas. Where are the vehicles currently operating?
Sure. So right now we're currently testing in San Francisco, Las Vegas, Seattle, and then some various test sites. We're also just expanded our testing out to Austin and Miami. But of course, we'll focus on launching in Las Vegas and San Francisco in the near future. But those are basically the areas that we're testing currently.
Any cold weather testing yet in the snow?
So the vehicle has gone through its full normal vehicle validation, including cold weather testing. And so it's kind of, from that minus 40 to X amount of, or 0 to, plus 40 degrees C.
Yep.
Large range of a normal vehicle would go through for testing. It's kind of gone through that entire validation. Yeah,
Okay, good.
it's set up to go through that. We'll be driving in those environments. That's further down the roadmap. We won't be doing that at first.
Fair enough. Um, I'm still fascinated by the fact that you guys developed a vehicle from the ground up rather than retrofitting, and especially with the asymmetric. Were there any major legal battles to get that approved? Because I imagine that's a long
That's a
part of
good
your 9-year
question.
span.
I wouldn't say major legal battles. I would say just a really concerted approach in terms of how we were going to go about that process. We have a great regulatory team within Zoox, led by Amanda Prescott. And really, what was going to be our approach in terms of self-certify or ask for exemptions? That's something that we had to figure out very early on. We believed we had a really good case in terms of for self-certifying in terms, based on the regulation, based on what was being asked of that regulation, how do we build a case to say that we've achieved that internally? And we think we've gone above and beyond in many regards in terms of satisfying those specific targets. And so for us, I think, again, what is the best solution to the problem that we're trying to solve kind of drove this ground up vehicle process. Is not just the look and feel or the rider experience. Ryan's alluded to a lot of the engineering opportunities that we have with a ground up vehicle, from not only the AI side, which a regular vehicle is simply not designed for, from an architecture standpoint, from a field of view standpoint, from a structural standpoint, from a thermal standpoint, electrical. There's a lot of knots it's not designed for. And so you're kind of gutting a regular vehicle anyway. And at the end of the day, if you achieve that self-driving, what's the thing that's going to matter? Well, the rider experience is going to matter. And so we really wanted to highlight that from the beginning and really incorporate that from a ground up approach, because at the end of the day, we think we have that, we have this fully electric, fully autonomous, 5-star equivalent crash for every single rider, full redundant type of hardware product tailor-made for a robotaxi service that happens to look like a concept car. And we were only able to really achieve that by doing it from the ground up at the very beginning and having a clear vision of what we wanted to do, with, frankly, a lot of champions at Zoox that were, not saying no to things, that were really saying, let's see how we can do this. And that spreads across not only the design and engineering side, but the finance, the manufacturing, the strategy, the regulatory, the policy side, the safety side, across the board. everyone had that tailored vision of, okay, how do we get this done? Let's make it work, which is why we think we've delivered this really cohesive looking product at the end of the day, which is now driving on public roads, and we're able to take it every day that we're at work, and it's been really, really cool.
Are there any plans to expand outside the U.S.?
I would love to say we're going to do that at some point in the future. I think, internally, it's we want to really bring mobility for all, right? That's something of an approach I think autonomy can really unlock for people. It doesn't matter who you are, where you are, what you look like, how much money you make. How do you make transportation ubiquitous? I think that's something really amazing that a robotaxi like ours can do. And so, we kind of have a crawl, walk, run approach. Obviously, we're crawling right now, but I'd love to be able to say in a number of years or even decades, wherever that may take us, that, you can take a Zoox at any point in time, at any place you'd like to. It's the same experience in one city versus the next. So hopefully in the future, we'll be able to talk again, and we'll be able to say that, we're really expanding out there. But until then, we're really kind of just leveling out the foundation right now of our service and our operations.
Okay. To someone who's very against robotaxis, how would you persuade or entice them to even take a test ride?
Ryan, you want to take that one?
Well, I mean, I think maybe a nod to a program that we've been enjoying so far at Zoox, which is our family and friends program. So we've been taking some folks on rides, throughout the company, and it's really, very various levels of adoption there, right? I mean, you've got folks like my parents who were stoked; they couldn't wait, right? Like they've seen me working on this thing now for almost 9 years, and uh, Zoox has been really going at it to try and get this robot on the road, and they were thrilled to step inside it and experience that ride. I think for customers or friends or family that are a little bit more cautious, I think what we've done is we've really tried to set up a vehicle that from the outset has a very friendly appearance and demeanor, if you will. I think the personality of our vehicle, just by kind of looking at it and seeing that inviting sort of shape and the way that the doors kind of open for you and welcome you in, even down to the sound design, to send that signal of comfort to the passengers, I think has been really key. And I'll say I've said this on a few other interviews in the past, but you sit inside a Zoox for the first time and you start riding, and it's incredibly quick when you start to realize that it's just like any other. You're basically you don't realize the magic after about 30 seconds. It's kind of like you have that experience of aha, and you get in, you start riding, and then it sort of fades away, and you're like, okay, let me get to reading my book or getting on my laptop or my phone or whatever, right? And it's pretty incredible how fast that happens. I think a lot of people have felt that. That's kind of been my experience so far, and just talking with folks and interviewing folks that have experienced it. And I would say to anyone out there who's skeptical, to find the courage to give it a chance, and really experience that, because it's we certainly put a lot of effort into testing and validating, and safety is incredibly important to us. And I really think that most folks will be amazed and impressed when they sit inside one of these autonomous vehicles.
Yeah, and I would add to that too. There are going to be stages, and there's going to be different groups of people. You're going to get early adopters who are just really, excited about the technology. They inherently trust it based on the way, what they've maybe looked at some of our videos or some of our research or information. They're more excited about it maybe than anyone else, and they just need to try it out. And those are going to be great champions for us, and we think we can win them over with the type of product we've developed. And then inherently that will build more trust that, for people that see them riding in the vehicles, driving around and seeing it operate, and they get dropped off safely and they start to speak positively about it. That will grow to more and more people. We really want to be there for those journeys of each individual. To Ryan's point, Noel Battaglia, our lead designer on the vehicle, he's been with us for over 10 years now. His goal for it was to really make something approachable and trustworthy and timeless. And I think he's nailed that kind of design philosophy into something that's more like a modern carriage for people, rather than a robo-taxi, so to speak. That kind of brings a bit more of a romantic feel. And it, nothing really demands your attention, right? We're not forcing you to figure out what it is. We're very honest and pretty, kind of calm in its design and simple by design. And I think once you have that ability to first see the vehicles driving, you're curious, right? As long as it invites curiosity, we always want to invoke an emotional response for people through design. If you're not, maybe you shouldn't be doing what you're doing, but it matters, right? And we know that there's going to be people that love it, but there's also people that won't, and that's okay. For those people that won't, we don't want to disturb them. We don't want to create a bad scene for them. We don't want to be obnoxious for them either. Ryan pointed out to what we do from a sound perspective, and I think I like what we do from a sound perspective. We kind of use that as another design medium to create a really enjoyable experience. The vehicle has not only the regulatory side of a quiet EV sound, which we call aura, but really it has this pleasant sound when it comes up and picks you up. It kind of creates a sense of its space around you, that this is now your zone, right? This is totally yours, that you hear. Those are like the little bits and pieces that we've designed from the ground up to really be good stewards to the areas that we're in, which I hope for those people that might be really critical to AVs, they see Zoox as being different than, again, just a regular vehicle that is driving by itself. It is truly designed beyond just that pure goal of autonomy into really a great rider and also user and general experience that we're trying to achieve.
Speaking of being different, how did you come up with the name
Zoox?
Yeah.
Zoox. So Zoox goes back. Okay. So Zoox goes back to this feeling of like community, right? And it really goes back to this word zooxanthale, which is this. It's a small microorganism in the ocean that has this really kind of symbiotic nature around it. It's really around this ability to kind of live as one, right? And this idea of having transportation be this connecting fabric now within dense urban and urban, et cetera, areas that this vehicle can promote, right? Like, how do we get to the point where we can remove cars off the road? How do we get to the point where we can open up sidewalks again or more park space? And regular vehicles are parked for 96% of their lives versus a robotaxi, which is used for 96% of its life. How do we make this a really communal event? Cars kind of dominate our roadways. As pedestrians or cyclists or those in public transportation, we kind of have to give way to these pieces of metal, right? And it's kind of a shame. And how do we make that such that where now the human is really the hero, right? And we think that is a really nice symbiotic way of living with something that it's necessary to move from A to B. We want to be the best option for that, and it's kind of really where Zoox came from in terms of its origins, and kind of goes back to what I just spoke to around the sound. That really symbiotic way of living within a balance with everybody is just really being considerate around everyone around you. We want the vehicle to be considerate not only to those that are riding in it, but those that are outside of it, those that have to interact with it from a driving perspective. We think that's just a really nice way to think about using AI as a technology, and in a really good way that everyone can really find benefit in.
Now, as far as engineering challenges, are there any challenges you are particularly proud of overcoming in this whole program?
Ryan, what do you think?
Yeah. Gosh, I mean, I think, thinking back over almost a decade, from the outset, I think even from the early napkin sketches, right? Just coming to Zoox and wondering where this was going to go. I mean, that initial challenge, I think, and overcoming kind of the what should this architecture be? What should this design kind of look like from a fundamental standpoint? I think those first few years, it was a challenge to work through a lot of those fundamental questions, especially when, didn't always have the benefit of, millions and millions of miles of data on public roads, right? And so I think, just kind of working through that together cross-functionally with a group of folks that, honored to have worked with, folks that are just incredibly smart, talented, driven people that have many different backgrounds and sort of experiences that they brought to the table to help work through these fundamental questions. I think that was a really exciting part of the process, there's kind of like early architecture phases. I think looking ahead at some of the challenges that we're excited about solving now, it's related to really getting this thing out there, for customers and scaling this. And I think that's going to present a different flavor of challenge than what we had in those first few years at the company, right? And so seeing that kind of evolution, the different problems that have come up, and having to work through those together as a company, has been a lot of fun, and it's been hard. It's been solving a lot of hard problems together. So
Yeah, I think for me, there's a couple. There's like Ryan said, there's a lot of engineering innovation in the vehicle, and a product like this, which is from the ground up. There's a tremendous amount of patents across all the different technical groups, et cetera, and design groups, which is great. It's fun. Holistically, though, I worked at Google Chauffeur, what is now Waymo, before coming to Zoox. I worked at Tesla before that and Honda before that. So always an automotive side for the most part, and some automotive places that were really innovative and pushing the boundaries, like Tesla, which was really cool. But to be able to take the initial sketches, the idea, the intent that we chose for the theme of this vehicle, and see what we have on the road today, which is incredibly similar and very rare. Usually you see a cool concept, you're like, oh, I love that, right? Like design studios can make anything look cool. That's what their job. Having it come out of that and go through all the machine that is a production vehicle and actually hit the road, and it's very different. You're like, oh, like I like that. Why did I get this? But then seeing what we've been able to do for a brand new product, I think is a tremendous celebration of all the engineering accomplishments we've been able to achieve as a team, that only comes about by having that synergy of a small working group really working closely together. And I think doing it from the ground up, there's no playbook for this. We didn't really have ability to reference a specific product. We had to pull from different areas in general to deliver this thing to the public road, and it lands and it looks just as it does today, we think, and we're very proud of that, and achieve all the goals that we wanted to achieve. That's what I'm most proud of. I think that's the coolest thing that I've seen. That journey takes a long time, right? In terms of vehicles, we're beyond a normal vehicle timeline. Usually it's 5 or 6 years, and we're kind of, getting to that space in terms of the 8-year time frame now with the vehicle. And I think, that is just something that allows us to also continue to push. We know it's possible. We're driving now. We've got people in it. Because we own and operate our own vehicles, we have continual improvement. So to Ryan's point about especially AI advancements, we don't want to hold that back, right? We don't want to say, oh, here's a cost target, we got to eliminate a sensor, or why don't you just go to this type of sensor? Like, we haven't solved the full problem yet. We want to really set up this piece of hardware to unblock that. And we're really proud, I think, of bringing that to the road. And at the end of the day, getting people in it to just simply enjoy it.
yeah, and just kind of building on that a bit more. I would say one thing I'm proud of, in addition to kind of just working through these challenges with all the teams, it's really, I think, the mindset. And Chris, you said something just now about we're going to make them use this tiny thing because it, matches a certain design philosophy. I think our mindset across the groups has been really, first of all, focused on one product, which I think has been really an awesome experience at Zoox, right? There's not a lot of distraction, right? There's one ground up robotaxi that we've been developing together. But I think the mindset around it has also been really nice and consistent, meaning that, the way Chris and I work together, when his team comes and says, we have this concept for how we'd like something to look, the look and the feel, it's never a demand, right? It's always a conversation. And I think that's a really important aspect of the Zoox culture and mindset is we have these conversations, and it's like, hey, could we do XYZ? What would it take to do XYZ? And then we have that sort of back and forth. And, I think I'm really kind of proud of that environment that we've been able to foster, to have those hard engineering conversations as we work through this thing that kind of nobody's done before, right? So that's been really exciting.
Okay, so last question, because we're kind of on the time here. If you had to start all over again, what do you wish you knew sooner than you do now?
Oh man, well, that's a two-parter for sure. Like, we probably have different takes. Ryan, go for it.
Well, let's see. I think benefit of hindsight. I think I will say I'm happy with where we ended up with our product design, right? So when we look at where we have ended up with the product that we want to deliver to our customers, I think, given all the constraints and how we got here, all that put into a blender, it's super exciting. This is going to work, right? I think 10 years ago, we were kind of asking the question, like self-driving cars, like how long and how will this work and how will it come together? And now, instead of asking those questions, we're starting to talk a lot about building a business, right? And those are the questions, right? So I think all in, we've gotten to a really good place. And so when I think, what would we do differently, and the benefit of hindsight, I really just think about getting to where we've got to today faster, right? It's just kind of like, could we have shaved off time and just gotten this wonderful product that we want to celebrate with the public, even sooner, right? And I'm sure the benefit of hindsight and knowing the problems that we've encountered sort of along the way, it's hard for me to point to any one thing that really was like, oh man, that was the thing that slowed us. It's really just a combination of lots of hard engineering problems that all need to kind of come together and developing this thing from the ground up. So I think, if we knew everything we know now 10 years ago, we probably could have gotten here a little bit faster, which would have been nice. But am quite happy with how we've ended up, and certainly really proud of the product that we're excited to share with the public.
Yeah, absolutely. Ryan took the words out of my mouth. I think getting to where we are faster would be amazing. I think there's, again, not a set roadmap for autonomous driving in every situation that I think people are expecting, right? And so, lessons learned for us that we're continuing to implement today is how do we move faster for things in terms of lessons learned, especially around driving and simulation. How do we make sure our vehicle is ready to go faster, in terms of getting it ready for a service, and what does it mean to have a type of service? We can think of it in segments of terms of like the AI, the robotaxi side, building the service and then operating the service. And some of those areas, those are giant companies that sit in those spaces that, we have to build up as well. Being able to prioritize certain things, but, at the same time, Zoox isn't a large company, and we're a little over 2,500 people. We've been in existence for 10 years. And so, we've really put our resources towards developing the tech, which is going to unblock a lot of those spaces. And so we've had to pick and choose our battles, right? And we've always chosen the ability to build a safe foundation for self-driving, and that's probably been a little bit slower than maybe people expect. But for us, it's on the right roadmap to deliver the type of product we want. There are little bits and pieces on the vehicle that I would like to, kind of redo a little bit, and I hope to have that opportunity in the future. But nothing that's going to hold people back in terms of loving what we've delivered.
Right. Yeah, I agree.
Okay. Well, thank you very much for joining us today. Thank you very much for sharing everything. I'm looking forward to trying out one of these vehicles and possibly tearing one down at some point.
Yeah, well, we can't wait to get you out there and to actually get you in a ride. We're very happy to and looking forward to be able to do that. And thank you for having us both on today. We really appreciate being able to talk to you, especially about the technical details. I think that's an area that we don't always highlight, and so it's great to get those questions in an audience that's interested in that as well.
All right. Thank you.
Thanks a lot, Chris.
Thanks, Chris.